Hello, you are most welcome. I'm teacher Ivan from Wunna Educational Services. Today we shall be looking at the empirical formula and the molecular formula. This is our third lesson concerning moral concepts. So if at all this is your first video with us, please just go to our playlist, go to O-Level Chemistry. You find the other previous videos concerning moral concepts so that we move together as we enjoy together. Otherwise, empirical formula shows the simplest ratio of the number of atoms of different elements in a compound, and the molecular formula shows the actual number of atoms of different elements in one molecule of a compound. So that's the difference between the two. Empirical just shows the simplest ratio, whereas the molecular formula shows the actual number. And the empirical formula can be determined from the composition by mass of the constituent or individual elements that make up the compound. Let us look at examples. We have example 1, 2, and 3. In example 1, we are told that a substance contains 17.7% hydrogen and 82.3% nitrogen by mass. They want us to find the empirical formula. So this is how we shall read. First of all, let us look at the elements. The elements are, we have nitrogen and hydrogen. Then we look at the percentage composition of the two elements. The percentage composition of nitrogen is given to us as 82.3, while that of hydrogen is 17.7. And now we shall look at the number of moles. Number of moles. So how do we get this? We get percentage composition divided by the atomic number. So the atomic number of this is 14. Then this becomes 17.7 divided by the atomic number of hydrogen is 1. So when we divide, that is 82.3 divided by 14. We end up with the 5.88, and then this one gives us 17.7, and then we shall get the ratio of moles. So we shall divide by the smallest figure, which is 5.88. So this 17.7 divided by 5.88. This gives us a 1, 2. That is 17.7 divided by 5.88. That gives us 3. So that means that the ratio of nitrogen to hydrogen in that particular compound is 3 to 1, and therefore the empirical formula will be nitrogen is 1, hydrogen is 3. So that is how we shall write the empirical formula. Let us go to our example 2. In example 2, we are told that a compound contains 1.44 grams of magnesium and 0.96 grams of oxygen. They want us to calculate the simplest formula, that is probably the empirical formula of magnesium oxide. Yes, this time around we are given the composition by mass, not percentage. So the elements in the compound are 2, that is magnesium and the oxygen. Then we come to composition by mass. Composition by mass. This one is 1.44, yet oxygen is 0.96. Then we shall divide this by the atomic number. This one is 24, this one is 16, and what we shall get will be the number of moles. So when we divide 1.44 by 24, that gives us 0.06. Then when you divide 0.96 by 16, that gives us also 0.06. And now we reduce by the smallest, so that gives us the ratio as 1 to 1. And therefore the simplest formula or empirical formula, the simplest formula will be magnesium is 1 and oxygen is also 1. So that will be the simplest formula or empirical formula. That is how we find empirical formula. Then in our next example we shall look at how we find the molecular formula. So let us do that. That is example 3, which says that a compound Y contains 15.8% of aluminium and 56.2% of oxygen and 28% sulfur. So let us write the elements in the compound. We write elements. We have aluminium, we have sulfur, and we have oxygen. Then the percentage composition. Aluminium is 15.8, yet sulfur is 28, and oxygen is 56.2. So we shall get the number of moles. Number of moles is gotten by dividing the percentage composition by the atomic number. Atomic number of aluminium is 27. Then sulfur is 32, and oxygen is 16. So that gives us the number of moles of each element in the compound. And then when we divide, that is 15.8 divided by 27, that gives us 0.585. Then 28 divided by 32, that gives us 0.878. Then 56.2 divided by 16, that gives us 3.513. And now we divide by the smallest to get the ratio. So when we divide, the smallest is 0.585, 0.585, 0.585. So that gives us a 1, 2, that is 0.875 divided by 0.585. That gives us 1.5. And then when we divide 3.513 divided by 0.585, that gives us 6. So the ratio is 1 to 1.5 to 6. But we prefer the ratio in whole numbers. So we shall multiply the ratio by 2 to get whole numbers. So that gives us 2 to 3 to 12. And that means that the empirical formula will be aluminium is 2, yet sulfur is 3, and oxygen is 12. So we can even combine this and we get aluminium 2. Sulfur and oxygen have a common factor which we can take out to get that. So that will be the empirical formula. Then we are looking at how we get the molecular formula. The molecular formula is gotten by, we shall multiply, because remember we saw that molecular formula gives us the actual number of atoms of different elements in a compound. So we multiply this by n. And we are told that calculate the empirical formula, which we have done, and determine the molecular formula of Y if the molecular mass of Y is 342 grams. So when we get this, must give us 342 grams. And now we start multiplying. This was 27, that's the atomic mass of aluminium, times 2, plus this is 3 times 32, plus this is 16 times 4 times 3. This is to power or times n will give us 342 grams. Now we start multiplying. This is 54 plus 3 times 32 gives us 96, plus 16 times 4 times 3 gives us 192. Power times n must give us 342. So when we add, we end up with 342, n equaling to 342. So we divide by 342 by 342, that gives us n as 1. And that means that the multiple is 1, and therefore molecular mass is given by, so the molecular formula is given by aluminium 2, sulfur 3, oxygen 12 times n. But since n is 1, since n equals to 1, meaning that we shall remain with the same. So that gives us a final formula as aluminium being 2. So that would be the molecular formula. Otherwise, if n was any other number apart from 1, then that number could multiply these ones. So assuming n was 2, we could multiply this to 4, this to 6, and this to 20, 24. So that's how we get molecular formula. Otherwise, that has been our third lesson. Please, I request you to subscribe and hit the bell so that you get notified whenever we have a video, so that we learn together as we enjoy together. I'm teacher Ivan from Wuuna Educational Services. Hope to see you again. Bye bye.